regression analysis. So now start regression analysis. In the last class, we have already discussed the correlation. So after correlation, we will start regression analysis. So we have seen in correlation that there are two variables and the relation between these two variables. Suppose we have two variables x and y, and these two variables are correlated, means there is relationship between these two variables, either it will be positive or negative. So these two variables x and y are correlated, then there must be these two variables must form an equation. So first regression analysis. In regression, first we what is regression? Regression means back to average. This method is given by Galton in 1905, and regression means back to average. So suppose there are two variables x and y, and these two variables are correlated. Means change in one variable will affect the changes in the values of another variable. So suppose x variable is increasing, then what is the effect of the another variable y? Whether y is increasing or decreasing. If y is increasing, then we said these two variables x and y are positive correlated. If one variable is increasing and in respect another variable are decreasing, then we say these two variables are negatively correlated. So, so in a regression analysis, we just see whether these two correlated variables, in these two correlated variables, there which one is cause and effect. So in regression, we can estimate the variable on the basis of the given variable of one variable. We can estimate the values of the another variable. So suppose two variables, for example, we take one variable is height and another variable is weight. So we have two variables, height and weight. So in correlation, we have seen that if height is increasing, then weight will increase. And we say that these two variables are positive correlated. So height is increasing, then weight is increasing. If we say that if weight is increasing, then what is the effect of on height? Weight of someone is increasing, so there is no effect on height. So we say that in this case, weight depends on height. So height doesn't depend on weight. So weight is the variable, and this variable is dependent variable, and height is independent variable. So if there are two variables and these two variables are positively correlated or negatively correlated, then there is a cause and effect. Which variables depends on another variable. So if we have two variables, height and weight, so change in height will affect in the changes in weight, but not in changes in the weight will affect the changes in height. It means weight depends on height. Weight depends on height. So weight is dependent variable and height is independent variable. So suppose these two variables are termed as x and y, and these so now starting in regression analysis, we consider two variables x and y, and these two variables are correlated, means there is a relationship between these two variables. So what is the cause and effect? It may be that either x, there is possibilities that either x will depends on y or y will depends on x, because these two variables x and y is linearly correlated. So here is the two possibilities, either x depends on y or y depends on x. So these cause and effects can be termed in the equations. So if that these two variables correlated, then there must be an equation between these two variables, and we know that in equation one variable is dependent and another variable is independent. So we convert these two variable into equation. So there is two possibilities. One, if y depends on x, means y is dependent variable and x is independent variable. So this equation is known as regression equation, and this equation is known as regression equation or regression line, because the equation is linear form. Then we can say this is the regression equation or regression line y on x. Regression equation or regression line y on x means y depends on x, y is the dependent variable and x is independent variable. Another possibility, if either x depends on y depends on x or x depend on y. If x depends on y, so in short, we write this x on y, and this can be written as y on x. So this is the regression equations x on y, and you can say regression line x on y. So there is two possibilities. If the two variables are correlated, so either x depends on y or y depends on x. So here there are two possibilities, and these two dependent equations known as regression equation y on x, and another is regression equation x on y. Now the establish this equation, regression equation y on x, and the equation can be written as y is equal to a plus bx. This is the general equation of line, general formula of the equation. Y is equal to a plus bx, and you can also say the y is equal to mx plus c. So this is the regression line y on x, where y is dependent variable and x is independent variable. Suppose we take example, two variables x and y. Example. Suppose x is 2, 3, 4, 6, 8, and y is 5, 7, 9, 13, and 17, for example. So if you see, then and you will assure that these two variables are correlated because x is increasing, y is also increasing. So this is the x and y are correlated. Now you can, if someone asks what is the relation between x and y, and this relation can be written in terms of functional and also known as functional relationship between x and y. So what is the functional relation between x and y? So if you see this observation, then you will see that y is nothing but 1 plus 2x. If you take x is equal to 2, x is equal to 2, this 2, then you will get 2 into 2 plus 1, 5. If you take x is equal to 3, then if x is equal to 2, you will get y is equal to 5. Take x is equal to 3, then you will get y is equal to 7. So this is known as the functional relationship between x and y, and the equation between x and y, where y is dependent variable and x is independent variable. So this is the dependent variable. This one is known as intercept. This two is known as slope, and this x is independent variable. So here we are trying to establish this relation if we are given x and y, because this is the short example and easy example, then we can establish directly this equation y is equal to 1 plus 2x. If suppose we have a large data, then how to establish, how to find the relation between x and y, and this relation is, that is the functional relationship between x and y. So for this, to establish this relation, we will use the another method, and we are coming to that. So here, this y is, suppose this is the dependent variable and independent variable. This equation is not exact, but this is the estimated value. If we take here some error, then we can calculate the exact value of y. So this is y is equal to a plus bx plus some error. Similarly, the regression equation x on y. This equation can be written as x is equal to a plus by plus some error. So you can use error, and otherwise we can write, if we ignore this error, we can take this value as a estimated value of this. This can be written as y estimated is equal to a plus bx. Then we ignore the error, then the after putting the after solving this equation, you will get the value of y, that is the estimated value of y. So estimated value of y is equal to a plus bx. Similarly, from this you can the estimated value of a plus by, estimated value of x. We just put the cap on variable, that is the estimated value, not exact value. So in that case, we have to find the value of a, b in case of y on x, and a and b. This a and b and this a and b are different. This A and B is used for y on x, and this A and B are different numbers which is used for x on y. So the question is how to find the value of A and B. So finding the value of how to find the value of A and B, and this value of A and B can be obtained by using method of least square. So just see how to find the method of least square. Method of least square. And suppose we have the observations x and y, and this is the scattered plot, the value corresponding to x and y. Suppose this is the value of x and y. Now we draw an estimated line, that is y is equal to a plus bx. This is the estimated value of y. So here the corresponding each value of x, you will get the estimated value of y. On this point you will get the estimated value of y, but this point, this is the actual value of y. So difference from this, the difference from the actual value to the estimated value is nothing but this is the error term. So in least square method, we just minimize this error. Okay, this is the actual values of x and y, and we plot the x on y axis, the corresponding values of x and y, and we estimate y on x. This is the estimated line, also known as regression equation y on x. So this is, suppose this is the estimated value, estimated lines. On this point, on this line, you will get the estimated value of y for the given value of x, but the actual value of y, this is the original point. So difference from this estimated to this actual value of y, this vertical difference, this vertical difference is nothing but the error. So first, this is error. So in method of least square, we just minimize this error. So suppose y on x, this is the regression equation y on x, and the actual value y will be obtained as y is equal to a plus bx, and plus some error. Okay, now just take the error. Error is equal to what? This is the y minus a minus bx. And see here, because if some value is lower than this estimated value, and some value is upper than, greater than this estimated value. So difference of this and difference of this. Some differences are in negative and some differences are positive. But if you sum, then it will become a zero. But in this case, we just square this difference. So first square this difference to ignore the minus sign. Because some error will be plus 1, some error will be minus 1. If you total this, so this will be 0, but here is the difference is not 0, because the difference is here, this difference is minus 1 and this difference is plus 1. So if you just add total difference, then it will give you 0. To remove this disadvantage, we just square of this difference. So squaring, so first we take the square. So squaring, after squaring the e square, this become e square is equal to y minus a minus bx, and this is the squaring. Now taking all error, so sum of error. So this is sum of e square is equal to sum of y minus a minus bx. Now differentiating, we this is the minimize error, the equation. This is the equation of the error. So our aim is to minimize this error. So in minimizing the error, we just differentiate with respect to this a and b. For what value of a and b the error will be minimum. So for this we just differentiate with and equal to 0. Now differentiating summation a square by with respect to a and equate 0. So this become 2 summation y minus a minus bx, and this is minus 1, this is equal to 0, and this will give you y summation y minus 2, take this side and it will be 0. So a sum of a, this is constant, so na, and this is the minus sign, so it will be summation a minus and b summation x, and this is equal to 0, and you can write this summation y is equal to na plus b summation x. This is one equation. Similarly differentiate with respect to b, and the same equation is differentiated with respect to b. So this is the equation 1. Now differentiate it with respect to, this is the summation e divided by differentiate with respect to b, and this will be 2 summation y minus a minus bx, and here minus x and equal 0. Now after solving this you will get summation xy minus a summation x minus b summation x square, this is 0, and you can write this summation xy is equal to a summation x plus b summation x square. So this is the equation 2. So using these two equations, like this is the star equation 1 and this is the equation 2. From these two equations you will get the, from 1 and 2 you will get the value of a and b. Similarly this is the y on x. Suppose this equation is x on y. Here we take the x on y, x on y. So here you see this is the value of x. Now the what horizontal difference, horizontal difference, this difference, this difference, this difference. So this is the error. So this is the estimated value of x is equal to a plus by. So similarly you just square this error, then sum and differentiate with respect to a and b, then you will get, so we, if you do the same for regression equation x on y, that is x is equal to a plus by, and you will see after doing entire process you will get summation x is equal to na plus b summation y, and summation xy is equal to a summation y plus b summation y square. So here these two equation. This equation is for regression equation x on y, in which x depends on y. You will get this equation of straight line x on y, and this equation is known as the normal equation of this. And using this equation you will get the value of a and b for regression equation x on y, and from these two equations you will get the a and b for the regression equation y on x. Okay. So this process and this equation, normal equation, obtained by using the method of least square. Least square means least square of error. First we take error, then squaring and minimizing them with respect to a and b. Okay, now taking an example. Suppose we have an example in which x and y, two variables, and the values of these two variables are given as 2, 4, 6, 8, 10, and the value of y 5, 7, 9, 8, 11. Now we want to find the regression line. Regression line x on y and regression line y on x. So we know two regression line, First is y on x, in which we have to establish the relation between y and x. So estimated of value of y is equal to a plus bx. So here we have to find the value of a and b. And another case, we want the regression line or regression equation x on y. For this we have to find or establish the relation between x and y as x is equal to a plus by. So these two equations, the basic difference of these two equations is that there are two variables x and y. In this equation, regression line y on x. In this equation, the y is the dependent variable and x is independent variable. In this equation, regression line x on y means x is dependent variable and y is independent variable. So obviously, if you have two variables and these two variables are related, then one variable must be dependent and another will be independent. So here we have x and y, and we want to establish these two relation. Whether if x depends on y, then what will be the equation? If y depends on x, then what will be the equation? So let us see. In both the equation, we have normal equation. Just we have seen in this equation, the normal equation y is equal to na plus b summation x, and summation xy is equal to a summation x plus b summation x square. In this case, summation x is equal to na plus b summation y, and summation xy is equal to a summation y plus b summation y square. So this normal equation is used to establish this relation, and this normal equation is used to obtain the value of a and y to establish this regression line or this equation. So in both the normal equation we have some requirement of data, and that will be summation x square, summation y square, and summation xy. So just prepare the table and of calculate x square, y square, and xy. So prepare this table because we have given x and y. Now x square is 4, 16, 36, 64, and 100. Y square will be 25, 49, 81, 64, and 121. Now xy is equal to 10, 28, 54, 64, and 110. Now take summation of these. So here summation x, and the summation x is 30, summation y is equal to 40, and summation x square 220, summation y square 340. You can check this calculation, maybe some error, then you can rectify. Summation xy 266. Okay. Now first we obtain regression equation. Regression line y on x, and we have to establish this equation in which we have to first find the value of a and b. What is a? A is intercept and b is the slope, and b is also known as regression coefficient. Regression coefficient of regression line y on x. Okay, so just put the value according to this, and you will get summation of y. Sum of y, this is the 40. 40 is equal to na. N is number of observation. This is 5a plus b summation x. B summation x is equal to 30b. 30b, and summation xy 226 is equal to summation a summation x. Summation x is equal to 30, 30a plus b summation x square. B summation x square means 220b. So after solving these two equations, these two simultaneous equation, if you solve this two equation, then you will get the value of a. After solving this, you will get the value of a is equal to 4.1 and B is equal to 0.65. So the if suppose these two variables x and y in which y depends on x, then the functional relationship between y and x will be written as y is equal to, that is estimated value of y, this is equal to a is equal to 4.1 plus 0.65 x. So this equation is regression equation or regression line y on x. What is interpretation? If x is independent variable, if x is changes by 1 unit, if we change in x by 1 unit, then y will be changed by the 0.65 quantity. If we change, if we increase x by 1, if we then y will increase by 0.65 quantity. So similarly, suppose if this in this question we also estimate. Suppose if y is if x is 15. Suppose if x is 15, so what will be the y? So we can estimate of y, and if x is 15, then put the value of x is 15, then you will get the value of y. So we can estimate also the dependent variable because y depends on x. So we will use this formula. And in another case, suppose x depends on y. Suppose x depends on y, then what is the equation? Regression equation, and this is x is equal to a plus by. This is the general equation, and this is also known as regression equation of x on y, in which x is dependent variable and y is independent variable. So establishing this relation, we have to find the value of a and b. So finding the value of a and b, we use the normal equation which we have obtained by using the method of least square. So we know the normal equation of x on y is summation x is equal to na plus b summation y, and summation xy is equal to a summation x plus b summation y square. Just replace x and y interchanging, then you will get. Now putting the value of these. So just put the value of here summation x is equal to 30. 30 is equal to 5a plus b summation y, and summation y is equal to 40. So this is the 40b, and summation xy, that is 226 is equal to a summation x. So summation x is, oh sorry, here is summation y. So 40a and plus b summation y square, and b summation y square is 340. 340b. So after solving these two equations, you will get the value of a and b. And what will be the a and b? A will be 4.4 and b is 1.3. B is 1.3. So just the regression equation x on y will be what? 4.4 plus 1.3 y means if these variable in which x depends on y and y is independent variable, so if you change the values of y by one unit, then the x will be changed by 1.3 quantity. So this is change, this quantity, this is the regression coefficient, this is changes by dependent variable. If this is the positive, so x increased by 1.3. If this is negative, then x will be decreased by 1.3 quantity. When we add one unit in y, then x will change by this quantity. So this is the case for regression line y on x and x on y. And in that case, you can also estimate the value of y. If suppose y is 12, then you will get the value of x by using this equation, because here x depends on y. So we use this equation. Here y depends on x. So we use this equation y on x. And A and B, in the both the cases A and B are different. So you can take another notation in place of A and B. We have A and B here and C and D for this x on y. So no problem, you can take another notation. Now this is the regression equation, and one more procedure for obtaining the regression line. If we are given the observation, suppose we just suppose we are given some information of two variables. Suppose we have the variable x and y, and we don't have raw data. We are just given what? X bar, standard deviation of x for this, y bar, mean of y, and standard deviation of y. Since x and y are correlated, then we also given correlation between x and y. So we are given only these of the values, this information, mean of two variables, standard deviation of these two variables, and the correlation between two variables. If we have only five information, suppose mean of x, mean of y, standard deviation of x, standard deviation of y, and correlation between x and y. Then how to obtain the regression line in that case? In this case, if we are given the raw data x and y, the values of x and y. If in that case, in which the informations are given in place of raw data, then we can also obtain the regression line using this information, and this is nothing but, so this in that case, regression line or regression equation both are same. Y on x can be written as y minus y bar is equal to r, means correlation between x and y, and standard deviation x divided by standard deviation of y. This is the standard deviation of y divided by standard deviation of x, and my x minus x bar. And this term, this is nothing, this term is known as regression. V, slope. So what we have seen in earlier equation, y is equal to a plus bx. In that case, b is slope, and this slope is also known as regression coefficient. Regression coefficient. Regression coefficient of y on x, and this can be also denoted by b in suffix yx, byx. This b can be written of byx means regression coefficient y on x. Similarly, in case of x on y, so x is equal to a plus by. So here this b is what? This b is regression coefficient x on y, and can be denoted by bxy. That is the slope. So here in that this quantity is nothing but byx, means regression coefficient y on x. Similarly, the regression line x on y can be written as x minus x bar equal to r standard deviation of x, standard deviation of y, and y minus y bar. This is the regression line x on y. In that term, this term, and this quantity is nothing but this is the regression coefficient x on y. This is the regression coefficient x on y. So you can use this equation also. Either you can use this equation or this equation. Now in this quantity and this quantity, the product of these two quantity means take from these two equation these two quantities, means this first quantity is byx multiplied by bxy. Then what will this multiplied by this? Then the remaining will be r square. So this cancel by this sigma y cancel by this, and r into r, that is the r square. So r is equal to square root byx into bxy, means this r is correlation coefficient and this byx and bxy are regression coefficient. So square root of these two regression coefficient is equal to correlation coefficient. So this is the relation between correlation coefficient and the two regression coefficients. And this is the r square, and r square also known as, so here is r square. We know r is the correlation coefficient, and r square means product of these two regression coefficient is known as coefficient of determination. This is coefficient of determination. Coefficient of determination, R square. What does it mean? R square means this is the quantity taken in percentage or fraction. This is shows the total variation. This quantity R square, fraction of this quantity, it shows that the total variation in the dependent variable are due to independent variable. That is coefficient of determination. Suppose using this example, suppose we have two variables, height and weight, and the correlation. These two variables are correlated, and the correlation between two. Suppose height are given and weight, the observations are given, and you find the correlation, and the correlation. Suppose height is x and weight is denoted by y. Then suppose correlation between x and y is 0.8. Suppose if you have given the data of height and weight, and you calculate the correlation between these two variables, height and weight, and you find the value of the correlation 0.8, because these two variables are positive correlated. So suppose you find the value of correlation 0.8. Now R square will be 0.64, and you can say 64%. So what does it mean 64%? That is the R square. This shows that the variation in Y, that is the variation in weight, the 64% variation in the weight are due to height. Means the role of height is only 64% in changes in weight. So the variation in weight, so height, weight is depend on height. So only 64% changes in weight are due to height. Another 36%, the remaining 36% changes in weight are due to some other factor which we don't have considered in my the example. So there may be some other independent variable or variable which changes in the or which changes in the weight of weight. So this is R square, that is the coefficient of determination. Okay. So the basic difference R and R square. R means R only shows the degree of association, how the two variables are, how they strongly correlated or weakly correlated. But R square shows how much percentage of variation in the dependent variable are due to independent variable. So in this case, in weight, only 60% changes in weight, 64% changes in weight are due to height. Means 34% changes in weight are due to some other variable, other independent variable. So this is the bivariate observation in which we only consider two variables. One is dependent variable and one is independent variable. Suppose in real life so many cases where more than two variables are involved. Some more example on this, then we will start multiple. Suppose we have two variables x and y, and these two variables are correlated. Then there must be an equation between these two variables. And suppose we say in this case y on x, y depends on x, and we have an equation like 3y, so 3x plus 4y is equal to 10. The equation between x and y is given like this. And in this two variables, y depends on x. Y is dependent variable and x is independent variable. So we can obtain the regression coefficient because this is the regression line. This is the regression line y on x. So just convert it in y on x form. If y on x, then the equation will be like this: y equal to a plus bx. So just convert, make this into this form, and here you take y is equal to 10 minus 3x, and this is 4, this is 4. So this quantity, so here this is y is equal to a plus bx. So this minus 3 by 4, this is nothing but b, and a is equal to 10 by 4. So this is the regression coefficient, that is b by x. The regression coefficient is minus 3 by 4. Suppose we are given two equations. Some more example. Suppose we are given two equations, and this is 3x minus 4y is equal to 15, and 5x minus 2y is equal to 20. Suppose we are given two equations, which means equation between x and y, and we are not given that which one is x on y and which one is y on x. In that case, what will we do to find the equation, that which equation is x on y and which equation is y on x? If we don't have any prior information, then we check which first left one equation in x on y, and some, just first you just assume. Suppose let equation 1 this is, and this is equation 2. So suppose equation 1 like x on y. Let just assume first equation to x on y. So in that case, what will be the equation like x is equal to a plus by. So just convert this into this form. So here x will be x is equal to 15 minus 4y divided by 3. So here you will get from this equation bxy is equal to minus 4 by 3. X is equal to a plus by. So b means regression coefficient x on y. Bxy is, you get bxy is minus 4 by 3. Then suppose equation one equation 1 is suppose x on y, then equation 2 will be y on x. If y on x, then equation will be like this: y is equal to a plus bx. Now convert the equation 2 in this form. So here y is equal to from this, so y will be minus 20 and minus 5x, and this will be 2 and this is 2. So here you get b yx is equal to minus 5 by 2. So this is bxy and byx. Now just find r, correlation coefficient, and we know the correlation coefficient is what? Under root bxy into byx. And now putting the value minus 4 by 3, minus 4 by 3, and minus 5 by 2, 5 by 2. So after solving you will get 20 by 6 and 10 by 3 and 3.3. If you calculate under root 3.3, then I think the value will be greater than 1 plus 1, because under root 3.3 is nothing but 1.2 something like this. That is the greater than 1. And we know that the value of r correlation, the limit of the correlation coefficient is minus 1 to plus 1. So here the correlation is beyond the plus 1. So it is not possible. This value may not be possible, the value of r never be greater than 1. So it means that our supposition was, which was I suppose, that was wrong, because this value gives that is not r. So in that case we just reverse our supposition. So now let equation 1 as y on x. If you take equation 1 as y on x, then you will get from here what is the relation. So y is equal to a plus bx. So y is equal to minus 15 minus 3x, and this is 4, this is 4, and this is nothing but byx is equal to minus 3 by 4. So you will get regression coefficient y on x minus 3 by 4. Similarly, from equation 2, then equation 2 will be what? Equation 2 will be x on y, and x on y, from equation 2 x on y. Okay. Equation 2 x on y, and from here x is equal to 20 x is equal to 20 and plus 2y, this is 5, this is 5. So here regression equation x on y is equal to 2 by 5. Now putting these two, so one is negative and other is positive value. So if you want to find the correlation, so it will give you complex number because one is negative, so under root negative and positive will give you imaginary number. So it is not possible also. So you can say this is not possible. This may not be equation, regression equation. Maybe some other. So using I will take another example. Suppose we just suppose plus this. In that case, so now suppose the equation 3x plus 4y is equal to 15 or 5x plus 2y is equal to 20. Then see how to obtain which one is regression equation x on y and y on x. Suppose let x y is equal to y on equation 1 is y on x. So in that case, you see y is equal to 15 minus 3x, and here this is 4 and this is 4. So this minus byx is minus 3 by 4. And from equation 2, this is x on y. So from here, x is equal to 20 minus 2y and 5, this is 5. So here you will get bxy is equal to minus 2 by 5. Now use these two regression coefficient. So you will get byx and bxy, because both are negative. So this is bxy is 2 by 5 and this is 3 by 4, and take negative outside because the correlation, the limit of the correlation is minus 1 to plus 1. So correlation may be negative or positive. If both the regression is negative, then correlation will be negative. If both the regression is positive, then correlation will be positive. If one regression coefficient is negative and other is positive, it may not be possible. It means there is something wrong. So in that case, this is 2 by 6 by 20 and 3 by 10. So if you calculate this under a square root of 3 by 10, the value will be less than 1. So here R will be, you can say R will be negative 3 by 10, and this is the within the limit. So you can say in that question, equation 1 is y on x and equation 2 is x on y. And you can complete. Now the next is regression analysis. We are discussing only two variables. If we have more than two variables, then this can be written as multiple multiple regression means one dependent variable and independent variables are more than one. Suppose, for example, okay. Mm, So multiple regression in real life, we always see that there is one dependent variable and independent variable may be more than one. Suppose yield yield of crop. Yield of crop depends on so many factors. For yield of crop depends on the fertilizer quantity of fertilizer, quantity of rainwater, quality of soil, and quality of seed. So you will see the yield of crop will depend so many factors. So this is the only one dependent variable, and these are the independent variable. So in that case, we use multiple regression and multiple correlation, in which de- dependent variable is one and independent variable is more than one, maybe two, three, four. So in that case, what will be the multiple correlation and multiple regression? Suppose dependent variable is y and independent variable x1 and x2. We are considering only three variables. One is dependent variable and another two are independent variable. So the multiple correlation, first we define the multiple correlation. Multiple correlation is obtained by this dependent variable and the linear combination of these two independent variables. If you make the linear combination of these, and this is suppose y estimated, because you know the y estimated will be the equation between x and y. So there is estimated value of y and this is the actual value of y. So dependent variable and linear combination of all the independent variable. So the relation between these two, relation between dependent variable and linear combination of all the independent variable are known as multiple correlation. Means in multiple correlation, one variable is dependent variable and another, because there are so many independent variables, so we just find a linear combination of all the independent variables, and the relation between the dependent and linear combination of all the independent variables will be known as multiple correlation. So here this is the dependent variable, and this y estimated is like a1 plus b1x1 plus b2x2. So this is the linear combination of x1 and x2. So this is the estimated value of y. So the relation between y and estimated value of y, this relation is known as multiple correlation. So in that case, multiple correlation is denoted by capital R, and the limit of multiple correlation is always greater than 0. So you can write the limit of R is 0 to 1. But in a simple correlation in which only two variables are involved, there are correlation, the limit of that correlation will be -1 to +1. But here is multiple correlation, the limit is from 0 to 1, because this relationship is obtained by the actual value of dependent variable and the estimated value of the dependent variable. So they are the actually the relation between two dependent variables, or original and estimated. So therefore the correlation coefficient never be negative, only positive 0 to 1. And the formula for this correlation, suppose we have three variables, suppose we are writing this like suppose x1, x2 and x3, then the correlation 1.23, correlation coefficient, multiple correlation is denoted by suffix, in suffix 1.23, means 1 means x1, 2 for x2 and 3 for x3 variable. So 1.23 means 1 depends on 2, 3. Here x1 depends on these two, where x1 is dependent variable, x1 is dependent variable and x2, x3 is independent variable. So the notation is written as R, capital R 1.23, and this is nothing but a square root R12 square plus R13 square minus 2 R12 R13 R23 divided by 1 minus R23. So this is the formula. If you are given the x1, x2, x3, then you can find the correlation, multiple correlation between x1 depends on x2, x3, like this. If here 2, then it will be changed accordingly. And you can also write the multiple regression analysis. So y, suppose x depends on x2, x3, you can write x1 on x2, x3. So this can be written as x1 is equal to a plus b1 x2 plus b2 x3. This is the general equation of, here x1 is dependent variable and x2, x3 are independent variable. Using the method of least square, you can find the normal equation of this, like here you have to find the value of a, b1 and b2. Here b1 is known as regression coefficient x1, x2. This is the regression coefficient between x1 and x2. b2, this is the regression coefficient between x1 and x3. You can write is b12 and like you can write b13. So the normal equation x1 is equal to na plus b12 summation x2 plus b13 summation x3 and summation x2, x1 x2 is equal to a summation x2 plus b12 summation x2 square plus b13 summation x2 x3, and the next summation x1 x3 a summation x3 plus b12 summation x2 x3 plus b13 summation x3 square. So using three not these equation is not normal equations. Using these three equations, you will get the value of A, B12 and B13. Where B12 and B13 is regression coefficient between x1, x2, and this is the regression coefficient between x1 and x3. Oh. So we are not going to take an example on this. You can do yourself. And next is partial partial correlation. Partial correlation is same as multiple regression or multiple correlation, in which suppose we are three variables x1, x2 and x3. In partial correlation, we just fix one variable and calculate the correlation between two variables. One variable is fixed. Suppose, for example, suppose we have a data like uh, height of grandfather, height of father and height of son. If we have three of data, now the height of son will depend on height of father as well as height of grandfather. But for the height of the father will also depends on height of grandfather. So in that case, we just fix this variable because this affects the height of both father and son. Height of the grandfather will affect the height of father and height of son. So in that case, we may, if you want, then you fix the height of grandfather. This is the fixed. Now find the correlation between these two, height of the father and height of the son. So fixing one variable and calculating the correlation between the remaining variable. So this process is nothing but the partial correlation. So if you have the partial correlation, then the formula is written as this is, suppose x, y and z. There are three variables and we fix the z. We want to fix the z. Then the correlation between x and y, correlation between x and y point z, written as, notation is written as r suffix in suffix x and y dot z, which we want to calculate the correlation between x and y while fixing the variable z. Z is fixed. So this is written R x y dot z, and this is the equation correlation between x and y minus correlation between xz, correlation between yz, and divided by 1 minus r square xz and 1 minus r square yz. So just see x y dot z. So first take here x y, correlation between x y minus the partial, because z x z where z is fixed, y z z is fixed, and here x y where z is without using z. So we find the correlation between x y and minus the correlation between x z and y z divided by this quantity. So this will give you the correlation between x y while fixing another variable z. So this is formula which is used to find the partial correlation in which one variables are fixed. And you can, this is correlation, you know the correlation we have already discussed in the last class, how to find the correlation between two variables. So you have to find the correlation between x y, correlation between x z, and correlation between y z. So if you are given three variables x y z, then you have to find the correlation between each of two. So this is the formula. Okay, now this topic is complete. Then the next topic we are going to discuss, and this is the test of hypothesis. Test of hypothesis. So test of hypothesis, and this is used in inferential statistics. And before starting this, what we are doing in hypothesis, if suppose first, what is the hypothesis? Hypothesis is any statement about the population. Suppose we have the population which we want to study. This is the population. Suppose this is the population, means which we are going to study. Suppose we are going to study, and you can say we want to know the average height of the student of integral university. What is our objective? I want to know what is the average height of the student of integral university. So the entire student of the integral university, the collection of entire student of the integral university is our population, which whose height we are going to measure. So this is the collection of entire unit, and this is known as population. Now, sometimes to study the entire unit of the population is not possible. In that case, we just take a sample using some definite procedure. So this is our population and this is our sample. And in sample, we just a part of the population, and we do a study of this sample. Suppose here the student 10,000 students. So in just we take the 100 student sample of 100 students, and we measure the height of these 100 students, and after finding the average height of this sample, we and we generalize this result for this population. So suppose it is claimed that, or someone says that the average height of the population of the student, average height is 6.1. This is the average height of the student of integral university. This is claimed by someone. Someone says that the average height of the student in integral university is 6.1. So this is just a claim. We have to verify this claim. So this is just assumptions about this population. Or this assumption, this answer said by anyone is known as hypothesis. So hypothesis is nothing but any statement about the population. And where population, so we just write some terminology. What is hypothesis? Hypothesis is any statement about the population. For example, someone says that average height of the student is 6.1. So this is the hypothesis. Next is, this hypothesis is population. Population is the entire unit, the collection of entire unit which are under study. And this is the sample, a subset of the population. It's a small part of the population taken to for study. So this is the sample. Now the hypothesis may be two types and written as, so hypothesis can be divided into two. First is null hypothesis, and second is alternative hypothesis. What is null hypothesis? This is denoted by H naught. Null hypothesis denoted by H naught, and alternative hypothesis is denoted by H1. Null hypothesis means no difference, and if there is difference, this is the alternative hypothesis. Suppose this is the population values, population parameters, and this is the sample. If we take a sample and we calculate the average height like 5.9, we calculate the average height of the student from the sample is 5.9. Now on the basis of this sample, we state that the population of the average height of this population is 5.9, but the actual and may not be actual, but it is stated that the average height is 6.1. So there is some difference. This is the parameter, and this is known as a statistic or estimator, because this is calculated from by sample values, and this is calculated by population, entire values, entire observation of the population. So we see here 6.1 and 5.9, some differences. Now the question, whether these differences may ignore or may not be ignored. Whether this difference is just by chance, and this difference is due to some extraneous factor. So now in null hypothesis, we just assume that this differences is no difference. Means we just go for the population, and this population parameter is always known as population mean mu. So this is the null hypothesis. In null hypothesis means there is no difference between the sample or population. But in alternative hypothesis means there is this difference. There is difference. So if you go for population, so null hypothesis can be written as H naught mu. This is what is claimed that mu is equal to 6.1. So null hypothesis means since this is different, but we say that there is no difference and we support this claim. This is the null hypothesis. Alternative hypothesis means there is difference. This is not equal 6.1. Okay, so either it will be true or this true. If mu not equal to true, this is known as two-tailed test. Two-tailed test because there is two possibilities, either mu greater than 6.1 or mu less than 6.1. If we can write this like this, if mu is equal to 6.1, otherwise mu greater than 6.1 or mu less than 6.1. So in that case, if we, so these two are called one-tail test. One-tail test. So either you can write mu not equal to this or either one of these mu greater than 6.1 or mu less than 6.1. So here this is one tail test because you take either one of these or this is two tail in which there are two possibilities that mu greater than 6.1 or mu less than 6.1. So this is the null hypothesis. Null hypothesis is tested for the possible rejection. Either you accept or reject the null hypothesis. If null hypothesis is accepted, means if this is accepted means mu is equal to 6.1 means there is no difference. This difference is just by chance. We just support this claim. If at H naught null hypothesis is rejected means this difference is exist and we cannot support this claim on the basis of this sample. So this is the null hypothesis and alternative hypothesis. The next term is error type 1 error, and this is denoted by alpha, and alpha is probability that rejecting H naught given that H naught is true. If you reject the true statement, suppose this claim is true, obviously this is the valid, but we have taken a sample. On the basis of the sample we get another value 5.9, and this hypothesis is rejected, and we claim that our sample is not supported to this claim and we reject this claim, but obviously this claim was right. So in that case, this is the error. So this error is known as type 1 error, in which we reject the null hypothesis given that the null hypothesis is true, and this is denoted by alpha. The second type 2 error, this is denoted by beta, and beta is equal to probability of accepting H naught given H1 is true. Accepting H naught given H1 is true. We accept the H naught Sometimes we accept this, but after some time it is given that this claim was wrong. So we accept the wrong claim. This is the type 2 error. Means accepting H0 given H1 is true. We accept the claim which was not true. We support the person who is not true. In that case, okay. So the next term is type 1 error. This next is level of significance. Level of significance. This is nothing but alpha type 1 error. So if you say if you give any statement in level of significance, if you are giving some statement and you are not 100% sure, then you say that you are 95% sure, you 99% sure. Means if you are 99% sure, means 1% the chance that your statement may be rejected. So this 1% is nothing but level of significance. If you are 95% confident, then there are 5% chance that your statement may be rejected. So this 1% and 5%, the chance of rejecting the hypothesis is known as level of significance, and this 99% and 95% is the confidence level. So this is the confidence level, and this is level of significance. Generally 5% level of significance, 5% is taken as level of significance. And one more term which is always used, and this is the degrees of freedom. Degrees of freedom. Degrees of freedom, this is the independent values, number of independent values. Suppose we are given three values, x1, x2 and x3, and the relation between these is like this: x1 x2 plus x3 is equal to 100. Suppose sum of these is 100. So here any one of two, suppose x1 you are free to take any value. If x1 x2 x3 is 100, some of these three values are 100, so you can take x1 any value. Suppose you can take x1 2, you can also take x2 any value which you want. Suppose you take x2 is 40. Now you are not free to take any value for x3 because x1 x2 already you have taken independently. So x3 is nothing but x3 is always be 40. So here two values are free, but one is depend on these two. So in 3 there are two values are free to have freedom. So if there are n observation, then n minus 1 have freedom to take any value. So this is the number of independent value. If there are n observation, then n minus 1 observations is independent, and this is the degrees of freedom. So now we stop to here, and we will continue next time. Okay, thank you. If you have any query, then you may ask. Thank you. दिख रहा है
Dear students, you can always use your laptop for better visibility. And in the chat box, students were writing that they have submitted their attendance on 29. Attendance is being submitted for 4th February, and usually whenever we are taking the attendance, it will be submitted only once. So no, don't worry that you have to submit it again and all. We have already received good number of responses. More than 200 responses have been received, and it has been recorded for 4th of February.